Hello everybody, this is Mr. Johnson and this is a video to help you guys with a little bit of the statistics notes for today. Game plan for this Friday is that we'll do a warm-up problem here, actually about the ACT and the SAT, a couple of tests, and then you guys are going to have the rest of the time to work on your homework. And you really need to make sure that you're working on it and trying to figure some of these questions out, because that's how you grow and that's how you understand the material. But to get started, we're going to talk about the SAT and the ACT and those scores. So since most of you guys are seniors, hopefully you guys have taken that test and you can relate to this a little bit. So let's go ahead and let's read this question in the notes. It's one of the extra practice problems at the end. It says, there are two major tests for readiness for college, the ACT and the SAT. ACT scores are reported on a scale from 1 to 36. The distribution of ACT scores in recent years has been roughly normal, with a mean of 20.9 and a standard deviation of 4.8. Now, SAT scores prior to 2005 were reported on a scale from 400 to 1600. SAT scores have been roughly normal, with a mean of 1026 and a standard deviation of 209. The following exercises are based on this information. So we have our information. We have some probably pretty important numbers here with like the 20.9, the 4.8. Those go with the ACT. And then with the SAT, we have 1026. So maybe I'll change colors. 1026, 209. Those go with the SAT right here. So Jose scores 1,287 on his SAT. Assuming that both tests measure the same thing, what score on the ACT is equivalent to Jose's SAT score? So what we're looking for is where he took the SAT, what would a similar score be on the ACT if you were to take that? So we're probably going to need to compare some z-scores here. Now, if you were to draw a picture, and I always think drawing a picture is definitely a big help here. We would have a picture for the ACT, and it looks like this. So here's my curve. We know the middle is 20.9. It is mu, or the mean. And then you can draw 1, 2, 3 tick marks out in both directions. And that covers pretty much everything. Remember, 99.7% of all the area lies within 3 standard deviations from the mean. And so we know S is 4.8. So this distance right here, 4.8. So you could just keep adding 4.8 and you'll get these particular scores. Now, I don't know if we need those scores to answer this question. I think it's just nice to know the situation. So that was the ACT. Let's go ahead and let's draw our diagram for the SAT. So here's the SAT. Draw our curve. We got the middle. 1, 2, 3 to the right. 1, 2, 3 to the left. The middle, the mean here is 1026. And then the distance between each tick mark is 209. That's our S. So that's X bar. This is S. X bar. This is S. So Jose scored 1,287. That's his particular score. Can I figure out where he would fall on the SAT? Obviously, he's doing better than the average. The average was a little over 1,000, so he's not bad. He's above average. So if we were to find his particular z-score, we're going to have to use that formula from last unit. So remember, that's x minus x bar over s. His particular piece of information minus the mean divided by our standard deviation. So we have 1287 minus the 1026 all over 209. That was our S. So if you put that in your calculator, you're going to get a decimal. And this decimal is 1.2488. And it keeps on going. Now, that is a z-score. That means his score, if you were to plot it out on the curve, it's going to be a whole standard deviation away, and then about a quarter of the way to the next standard deviation. So he's roughly right about here, which is not bad. I mean, he's above average by a decent amount here. So what we're trying to find is what ACT score is equivalent. Let's see. So we need to be in the same spot on the curve, right here. So if his z-score was 1.24, we're going to have a z-score of 1.24. Okay, and I'm going to include a couple of decimals in here, 1.2488. Now, we want to know his particular information, like his score. So that would be X. And I think we know some of the other information. We know the mean, that was 20.9. And we know the standard deviation, 4.8. So you have to know what you're given. And then you have to be able to figure out how to use that given information. So here we need to solve for X, right there. So if we're solving for X, or we're trying to solve for X, I need to get rid of the dividing by 4.8. So I times by 4.8, those cross off. Times by 4.8. So 4.8 times the 1.2488, that is going to be 5.9942. And that's equal to X minus 20.9. So now just to get down to X, you add 20.9 and you add 20.9. So in the end, we get X equals 26.894. Now what does that mean? So that means if Jose scored 12,080 or 1,287 on the SAT, a comparable score on the ACT would be a 26.89 or roughly a 27. So if he scores that well on the ACT, you would expect him to probably score roughly a 27. So those would be comparable or equivalent scores if you had to compare across these. They are in the same position. The same area lies below the curve over there as the same amount of area lying below the curve over here. It's the same proportions. So let's go ahead and let's maybe try the second question here. A different scenario. Reports on students' ACT or SAT usually give the percentile as well as the actual score. So Tanya scores 1,318 on the SAT. We want to know her percentile. So if she scores 1,318, that was her particular score. So if you go back and you compare it to the average, this was our average right here, 1026, she's doing pretty well. In fact, she did so well she was actually higher than Jose. So we would expect her to be in a higher percentile than what Jose would be. Let's go ahead and let's find her z-score. We need to find z equals, this was her particular information, so 1,318. We subtract the mean, 1026, and we divide by the standard deviation, which was 209. It's the same numbers from above. We're just dealing with a different person. So if we go ahead and put that in our calculator, we get 1.39712. And you guys need to be double checking me with some of these. I make mistakes just like you might make mistakes. And if you compare these, okay, just a little bit of a logic test. Jose's was 1.24 Hers was 1.39, and she did score a higher score, so this makes sense. Her z-score should be a little bit higher. She's further up on the curve. Now, this number is a z-score, and I think one of the things people are really having trouble with is the table, like what is it dealing with? This is a z-score. Let me go ahead and let's go to the table real quick. The table is comprised of two different ideas. You have an idea that is on the outside. These are z-scores. Those are the tick marks at the bottom of your graph. Everything else, everything in the middle, all of this is the area, or you could also think of it as percentage. So if you are given the area, you will look in here. If you are given the z-score, you will look out here. So based on what you are given, you know to either work on the border or whether to work on the inside. Okay, and that's being able to identify those things is huge. Really, really, really important. So for our problem, if we go back, I think we were given a z-score. Yeah, we were given her z-score and it's 1.39. So for the z-scores, we need two decimal places. So remember 1.39, and let's go to our table. So one side has got negatives. We don't need negatives. We need positives. So we go here, and 1.3 is in this column. And then we need to go out to the 09, right there. So 1.309. So we're traveling along. Now we've finally gotten to this column. So that is 0.9177. So 0.9177 is the percentage or the area. So she's up here, 0.9177. So what percentage is this part, this shaded region? The shaded region is 91.77%. So if we were looking at her percentile, that's the percent of people that she had a higher score than. So she was in the 91st percentile. So if they would have given her score, they would have said, hey, a score of 1,318 on our SAT, that puts you in the 91st percentile. You beat 91% of people, and almost 92%. She would have scored a little bit better. So I think the big thing here is recognizing that this is a z-score. So you should look on the outside of the table because that's what the z numbers are. If you had been given the area, like the 0.9, then you would have started in the middle, and you have to find that number. So being able to recognize those, very important. Let's try question number 3, and then this will be it for our warm-up. So the quartiles of any distribution are the values with a cumulative proportion of 0.25 and 0.75. Okay, and think about quartiles in terms of quarters. A quarter of the area, 0.25, and then 3/4 of the area, 0.75. So what are the quartiles of the distribution for your ACT scores? So if we draw a little picture, here's our middle, 0.25 is somewhere like right here. If we were looking at the 3/4, that will be somewhere right here. So this would be 0.25 or 25%. This is 0.75 or 75%. Now it is our job to figure out, hey, what number is this? What number is this? So if this is 0.25, we know that's 25%. This is 75%. And these things are area. So if we are given area, the 0.25 and the 0.75, on our table, we need to find that area. So if that's what we're given, that's what we need to find. So let's go ahead and let's go search for 0.25. So I'm on the negative side, I think, because they're 1s and 0.2s and 0.3s. So 0.25. So here we have some 0.25s, 0.25s, there's a 0.24. So you want to get the one that straddles 0.2500. So that would be this number and this number. And if you recall, we always take the lower of these two. So we're going to take 0.2483. And now we wanted the z-score. So if we look, we were in this row and we were in this column. So that is negative 0.6 followed by 8 in the 100th. So negative 0.68 goes with that area. And that makes sense. I mean, we're less than the mean, which is right here in the middle. So we should be negative in terms of our z-score. We were to the left. So that is our z-score. That will give us 25% of the population below it. Now, to find this third quartile, which is 75%, we need to find this area, 0.75. So if we go to our tables, we only get up to 0.46 down here, actually 0.50. So that's the first half. We're going to need to be in the positives. I mean, 75% is on the right-hand side. So we need 0.7500. We got some 0.8s, 0.79s, 0.73s right here. So if you underline these, 0.7486 and 0.7517, those would be straddling this number. So we always take the smaller, so I'm going to take the 0.7486, and we need to figure out, hey, what z-score went with that? So I just go to the left, 0.6. I go up with a 7, so 0.67. Okay, these are the hundredths, these are the tenths. Rough estimate, fine tune it. So 0.67. Now if you look at these numbers, negative 0.68, so you're about 0.68 below, positive 0.67, you're about 0.67 above, and we have 25% and 75%. It kind of makes sense that this should be an even distance below, as 75% would be an even distance above. And the only reason that we don't get like 0.68 and 0.68 is because we had to round and take the smaller of the numbers. These are exactly the same distance from the middle. Okay, if you think, here's 50%. If you go this direction, you'll get to 25%. And if you go this direction, the same amount, you would get to 75%. They're both equidistant from the middle. So that's good that we got numbers that are so close to each other. So these would be the z-scores for the quartiles. So on your homework, please go ahead. You guys can work with partners. I need you guys to really draw the pictures, go to the table, know what you're looking for in the table, and then try to write a little bit of a conclusion. Try to summarize your thoughts, okay? And anything that you put down, like any equations, any pictures, I'm going to look at that as work, okay? And you get points for that, and I'm seeing what you're thinking and what's going through your head. That's going to help me know how to help you guys. So the homework is due by the end of the day. If you guys could turn that in, I would greatly appreciate it. And if you have any questions, feel free to email me or leave them with the sub. Thanks, guys, and I'll see you guys next week.